Hello, this is Douglas Rumbaugh, and welcome back to my Linux Back to Basics command line tutorial, where I am going to endeavor to show you all the basics of using Linux from the command line. It's been a while since I put out it's been a long time since my last video, but figured I'd throw one out again. So today we're going to be talking about process management in Linux, but process management from the perspective of working inside of Bash. So what I mean by this is there's the operating system level of process management, which I'm going to talk about a little bit. But then there's job management, which is a slightly different, simpler version of it that works inside of the Bash shell. And since you are undoubtedly, if you're new to Linux, using Bash, it's a fairly good introduction, I think, into process management. Of course, we can't talk strictly about job management without at least defining a few terms here. So I'm going to start with process. Now, a process is basically any program that is executing on your computer. So there's the operating system itself has a number of different processes associated with it. This terminal emulator here is a process. And all processes are related to other processes. It's sort of a parent-child relationship. So you have processes which own processes. The simplest example of this that I can think of is this terminal emulator right here. This is a process that is running on this system. So if I were to, inside of this terminal emulator, launch my text editor Vime, Vime is another process. However, it is a process that is owned by the terminal emulator. If I kill the terminal emulator, I kill Vime. That's how that works. So let me just quit out of here. So in Linux, every process is tagged with a number called the PID, the process ID number. And it's this number that the system uses to keep track of the processes and assign resources and so on and so forth. It's also this number that you will need to do things like kill the process or change the process priority. This video is not going to talk very much about process IDs. That's the next one. In this one, I'm going to talk a little bit about job IDs, which are in many ways an abstraction of process IDs. So anytime I start a process inside of this bash prompt, it will be tagged with a job ID. And then I can, inside of this bash prompt, use that job ID in order to do various administrative tasks. So just to demonstrate this, I have a Python script here, jobtest.py, which is just going to operate in an infinite loop, print the word looping, sleep for 2 seconds, print the word looping. And I'm going to use this script to demonstrate how all this works, because we need processes that run for long periods of time. Now, historically, if I were to run this Python script, and you'll see it is printing looping to standard out, the only way that I've talked about so far in this series of videos that we can stop this process is with ctrl-c. Ctrl-c is the keyboard interrupt, and it tells the current process to knock it off. There are other ways to do this, though. So first, though, I want to talk about the difference between foreground and background. So processes can be either running in the foreground or in the background of this terminal emulator. And it's fairly obvious, I think, what this means. Right now, this jobtest.py is executing in the foreground. It is the only thing, or rather, when it is running, I can't interact in any meaningful way with this terminal. I can use Ctrl-C to abort the process, but say I were to type clear and press enter, it's not listening to me. It's not accepting my input. So I can, of course, use Ctrl-C, and that kills the process, and I can continue to work on the terminal as normal. However, there's another thing that you can do, and that is ctrl-z. So if I type ctrl-z, you'll see this message here pops up. 1 stopped jobtest.py. This This is the job ID that I alluded to earlier. So we've stopped job 1. If I were to run job test again and stop it again, you'll see I now have job 2. You can look at all of the jobs that are currently associated with a terminal emulator or a bash. Strictly speaking, it's with a bash session, but normally you only have one per emulator, so I'll use the two phrases interchangeably. If you type jobs, the jobs command, it will give you a list of all of the jobs that are associated with this bash session. And you'll see I have 2 of them. Both of them are tagged as stopped, and they're both the same actual instruction. So if I wanted to start something in the background rather than the foreground, there are a couple of ways I could go about doing this. When I have something running in the background, then I can continue to use the terminal. It will still accept my input and still do things. If you have a job that has been stopped, you can start it up again in the background by using BG. So BG stands for background, and if I type BG followed by a job ID and press enter, that's going to kick the job off in the background. You can see this ampersand here, that means background. You will note, however, that it is continuing to dump to standard output. I can still execute commands just fine. However, that standard output dumping gets a little annoying. In order to actually kill this, what I have to do, I'll show you a different way to do it later, but for now, I'll illustrate the foreground command, or FG. So if I type FG and then a job ID, it's going to pull it into the foreground. The F is up here, and then G1. It entered this looping thing in between, but that's not considered on standard input. That's standard output, so it didn't affect the actual FG. Anyway, we're back on the foreground now, which means I can't interact with the terminal, but I can pause it with ctrl-z. So it goes without saying then that if you want a job to work in the background, you probably should not, or rather you probably should redirect standard output. And I'm going to do that. So if we do job test, you'll recall from the previous video in this series that this ampersand greater than sign is going to redirect standard out and standard error to, we'll call it test.log. So now there's no output because it's all being redirected to that file. However, it's still running in the foreground, which means I cannot use my terminal. If I use Ctrl-Z, I'll pause the job. And just to give you an idea, the job is currently stopped. It's not running. So if I do a word count -L, so WC-L will give you the number of lines in a file, and pass in test.log, there are 6 lines. Now, this is printing every 2 seconds, so if we wait a couple of seconds and it were running, we would expect for the number of lines in the file to increase. But as you can see, the number of lines in the file has remained at 6. The job is not currently active. If I type BG, though, then I can put the job in the background and it will start running again. The job I want is this one, job ID 3. So if I type BG3, the job is now running. If I type in jobs, it says that the job is running. And if I go back and do that word count again, you'll see the number of lines in the file is slowly but steadily increasing. I'm going to stop that job again by pulling it back into the foreground and using Ctrl-Z to stop it. And you can see we now have 3 different jobs that are associated with this terminal. None of them are currently running. If we want to kill one of these jobs and make it just go away completely, then we need to use a new instruction. This is the kill command. Now, the name kill is a bit of a misnomer because it does more than that, but you will use the kill command to stop processes from running. What it does is it sends a signal to the process, and then the process catches the signal and handles it appropriately. You can send different signals by just typing dash and then the signal that you want to send. So say kill -1. If you do kill-L, that will provide you with a list of all the available signals. The default signal, if none is provided, is this one, sigterm, the termination signal. This signal will tell the program to, or the process rather, to stop running, but it's not going to force the issue. So most programs will catch that and then stop. It's useful because the program can catch it and it has a chance to respond, so it can close files and clean up after itself before it goes down. However, it can be ignored if the process is running a little bit too rampant. Sigkill -9, that's the kill signal. That will stop the process completely. However, it doesn't give it a chance to clean up, and the process can't catch it and handle it, so that could potentially make a mess of things depending upon the situation. In any event, let's say we wanted to kill my first job here. I would use kill, and I'm just going to send it a termination signal, so I won't provide any signal. And now we need to tell it which one to kill. Common sense says we should type 1 because we're killing job 1, but you'll find you don't have access to do that. This is not Linux saying that you do not have access to kill jobs that are working in your session, in your bash session. You do have access to stop them. However, we didn't specify whether we were talking about a process ID or a job ID. So remember, the process ID is that number that the Linux system tags processes with, and that process ID is for the whole computer, or the whole operating system. It's not for just this session, this bash session. So when I tried to kill 1, it defaulted to killing process 1. And process 1 is not something that you want to be killing. And it's not something that I have access to kill because it's owned by root. I'll show you how you can look all that stuff up in the next video. For now, what we need to know is that if we want to specify that we are killing a job and not a process, we use a %sign followed by a 1. And this is going to terminate job 1. So you'll see we got the little message here. And if we run jobs, job 1 is terminated. And if we run it again, it just disappears completely. So that's how you kill a job. You can kill a running job. In fact, let me show you how that works right now. I'm going to kick off job 3 in the background again. So now if we do a word count on that log file, 20, 21. If I now go and type in kill %3, job 3 has been terminated. So if I do a word count, 25, 25, 25, you'll see it's no longer writing lines to that log file. And furthermore, it's disappeared from my jobs listing. So I'm just going to kill this job as well. So we have no jobs currently bound to this terminal. And when you don't have any jobs bound to it, the jobs instruction is going to return a blank line. So just to review what we've gone over so far. Anytime that you start a program inside of a terminal, that program is associated with that terminal. It's a child process to the terminal process. And the terminal tracks it by giving it a job number. It starts at 1 and it counts down. If a job is running in the foreground, then you no longer have access to that terminal. It won't listen to your input except for the control sequences. So ctrl-c will interrupt it. Ctrl-z will tell it to stop. Once you've stopped it with ctrl-z, you can use either FG or BG to assign that process to run in the foreground or the background. When a process is running in the background, it doesn't interfere with standard input at all, so you can still type commands into your terminal. However, if the job has any output and you haven't redirected that output to a file, it will continue to spit the output onto the terminal, which can get a little annoying. So you probably want to redirect to a file if you're planning on putting the process in the background. Another trick is, say you know going in that you want this to run in the background. If you call job_test.py in this case, and I'm going to redirect to test2.log, if I were to just run this as is, it would of course start executing in the foreground. I could then pause it with ctrl-z and send it to the background using bg and then the job number. However, if I put an ampersand at the end of the line, that will tell bash to run this in the background automatically. So you'll see it's now running in the background. I do not have anything. I have full interactivity with the console back, and if I look at the number of lines in this file, you'll see it's going up. If I run jobs, job 1 is running, and the ampersand is present here as well, indicating that it is in the background. So I can now just kill that, like so. We get the message has been terminated, and we're back to no jobs running. Okay. So that's how you do that. There is one additional topic that I wanted to discuss today, and that is hang-ups. So I mentioned earlier that when you're running a job, or when you run a command from inside of a terminal, that command is associated with that terminal. If the terminal goes down, if you close out of the terminal, then the job running in the terminal also goes down. This is not something that you necessarily want to happen all of the time. As an example, if say you are working on a remote server, so you've used SSH. SSH stands for Secure Shell, and it effectively allows you to log into a computer over a network and will give you a terminal just like this. Except when you type commands into that terminal, you execute them on the computer you're connected to, not on the computer that you're sitting at. That works the same way as a virtual terminal in that everything you run is bound to that SSH session, and when you close that session, you kill all of the jobs that are running inside of it. There are two ways that you can, well, more than two ways, but I'm going to show you two ways that you can run processes inside of a virtual terminal or an SSH session in such a way that even whenever the session is terminated, the job continues to run. The first way is by using the nohup command. So if I were to, let me just clarify, there are no jobs running right now. So if I were to type nohup prior to whatever command I want to run, we'll say job test again, and I'm going to redirect this to test3.log, and I'm going to run it in the background. So now if I type jobs, you'll see I have job 1 running. And if I do a word count on test3.log, it is slowly but surely gaining lines. I'm now going to exit out of this terminal. Okay, so had nohup not been typed at this point, that job would have terminated because I've closed my terminal. However, if I open up a new terminal here, type jobs, there's currently no jobs associated with this terminal. If I do a WC on test3.log, let me put the L there, 24, 25, so it is still running in spite of the fact that I've closed out of the terminal that owns it. Now I'm going to quickly kill that process the traditional way, which I'm going to show you in the next one, so just bear with me. And I want 757, no, 739. Okay, so now if I did that right, then this log file is no longer gaining. Okay, so that has been killed by process ID, not by job ID. I'll tell you all about that in the next video. The problem with nohup is that when you use it, you have to know before you run the command that you potentially want that command to ignore the hang up signal and continue to run once a session has been closed. And you don't always know that going in. Say you're trying to run a script and the script suddenly starts running over the course of a few hours. You don't know it's going to run for 3 hours when you start it, but you can't sit there babysitting it for 3 hours, especially over SSH where your connection times out. In the event that something like that were to happen, though, there is a way around it. So, I'm now going to show you how you can change a currently running job to ignore the hang-up, even if you didn't specify it going in. If I were to run job test.py, and I'm going to redirect all of my output to, say, test4.log. Okay, it's currently running in the foreground, so I am going to stop it and throw it into the background. The file is growing currently. In order to make it so that this job will ignore the hang-up signal, I have to use the disown command. Now, disown does a few different things. This is just one of its functions. If you use disown with the tac h, and then the job ID preceded by a %sign and run that, that's going to tell the job to ignore any hang-up signals that happen to get sent its way moving forward. Once again, if I do a word count on this, you'll see that the line count is going up, 25, 26. So I'm going to exit and open up a new terminal. 33, 34, it is still running in spite of the fact that I've closed the terminal. So that's a second way that you can set a job to continue running once you've closed the terminal, is with disown. Alright, so just to quickly recap everything that we have talked about over the course of this video, you can put when a process is running inside of a bash terminal, it's assigned a job ID. This job ID is unique to the terminal, not to the entire system. So you can have multiple job ones across different terminal emulators, but you can use those job numbers to interact with these processes inside of bash. You can put them in the foreground with FG. You can put them in the background with BG. You can pause them by typing ctrl-z. You can kill them with kill, %, and then the job number, job ID, I should say. If you start a command by typing nohup followed by the command, then that command is going to continue to run even after you've closed your terminal. Alternatively, you can disown with the job ID a currently running job or command or process. I'm using them all interchangeably here. You can disown it, and then that will also tell it to continue to run even once you've closed out of the terminal. So that is all that I have for today. I hope that you found this video useful. If you have any comments or questions, please leave them in the comment section below, and I will see you again shortly. Thanks for watching.